Okay. Everybody back there? Great. Thanks for coming this afternoon. It's about time to get started. My name is Nathan Yergler, and I'm here to talk to you about effective Django. I'm a principal engineer at Eventbrite in San Francisco, and I've been doing that for a little over a year. Using Django since just post Magic Removal, which was pre 1.0, and before Eventbrite, I was CTO at Creative Commons. So I've been building web apps using frameworks for a while, and I think that's what we call talk today. I'm talking about how to use Django effectively. So did anybody here attend the Django bootcamp yesterday? Okay, great. So we're not going to do a step-by-step walk through how you build something. My goal is to leave you with a set of principles you can apply and a nice flavor for some of the deeper parts of the Django framework. So things that you might not see in a basic tutorial, but hopefully when you encounter these problems or you encounter things, you'll be able to think back and say, oh, right, I think there's something there. I need to go look at that. And so there's a lot of material, and it's sort of at a, we're going to skip along the framework quite a bit. Since this is a double session, I'm planning to take a break in the middle. If you need to duck out, that's totally fine. If you have questions along the way, please feel free to raise your hand and ask me at any time. If I'm in the middle of something, I might just ask you to defer it for a few minutes until we're at a natural stopping point. So they say you shouldn't bury the lead, and so I'm going to give you the TLDR version in the first slide, which is 2 points. One is the cohesion rules, and the second is you should look under the hood of Django. So what do I mean by cohesion rules? You may be familiar with this idea in programming and engineering of writing cohesive software. That's software that does one particular thing and does it well and doesn't try and mix up what it's doing. And so the principal things we're going to talk about today, the things are my opinion, and we talk about them, are going to be designed to help you write cohesive code, and help you write code that really focuses on doing one thing and doing it well. And it's been my experience that by doing that, you're going to write code that's more testable, more maintainable, and more scalable. And in fact, that's what I mean by effective Django, which is using Django in ways that you can write testable code, so you can actually write unit and integration tests for it without killing yourself or stumbling over your own feet. And that's going to lead you to write more maintainable code, so things that you're going to run in the long term. At Eventbrite, we have code that's been in service since 2004 or 5, and some of it's less maintainable than we would like. And so our goal as we write new stuff is to not repeat our past mistakes. And so I hope to tell you about some of those. And finally, if you write code that's maintainable, it's going to be scalable. And that's not just scalable in terms of how many uniques you can handle per day or how much traffic you can handle in a single box. I think about scalability in terms of what's the overhead generally of using this software. And so when we add an engineer to our team, that adds overhead, right? And there's overhead for them getting up to speed on our code and coming to understand what we've built so far. So if you're going to write something that's maintainable, you're going to minimize that overhead as you add people and as your project grows. So this is what I think of as my cohesive model for using Django. There are 3 sort of top-level things that get a lot of play in Django. There's views, there's forms, and there's models. And so when I'm working with a new Django project or existing code, these are what I try and think of as principles for applying things. A view's only job is to take a HTTP request and turn it into a response. So if your view is actually performing business logic, or your view is doing anything other than doing that conversion from A to B, then it's probably doing too much. Forms are something we're going to talk about in depth, and they're a way to take user input and turn it into Python objects. So this is down a little bit fuzzier, but that's the principle I try to think about it in. And finally, models are where your data and business logic live. And if you saw Brandon Rhodes' Python patterns talk earlier today, I'm actually rethinking some of this now. But generally, I think that this is not a bad place to start. So this is sort of what we're going to talk about overall. There's a bit of introductory material that's going to be very thin because the Django tutorial does a really good job of explaining a lot of the basics and introductions, but I want to sort of give an overview of some of these things. We're going to talk about testing right up front, and then again throughout the talk. We're going to talk about middleware, just because there are some gotchas there. Class-based views are something new that are very powerful, but very sticky sometimes. Finally, the ORM, the database layer, forms, and then I will thank you. Just so you know, you can find these slides if you're interested. Look at them at your leisure at effectivedjango.com. It looks like this. You can click the little double S and see the slide version. It's all very magical and Python-driven. So, right. First things first. When we talk about your application environment, your application that you're going to build, it's easy to start a project, right? There's this helper command that creates a bunch of stuff for you and puts a bunch of files in the file system where it thinks it should go. But what comes next or what comes right before that? Here's some things I recommend. first of all, thinking about deployment from day one. So when you start your project, imagine that you're going to deploy this right away, and assume that you're going to make. Let me rephrase that. I know that I make mistakes. When I have to do something manually, even if I have a checklist, I make mistakes, and those aren't because I'm bad at my job or because I'm negligent. They're simply because I'm human and I have a lot of things going on. And so if I can automate things, my life is going to get measurably better and my boss will get measurably happier. Those are both really great things for me. So if I think about deployment from the start, that's going to help out as I start to build out my project. So to do that, you're going to need a dependency management tool. There's a few different ones that I've used that I recommend whole or mostly heartedly. There's pip with requirements or virtualenv. So I assume a lot of people are familiar with virtualenv. If you're not, it's a great tool for isolating a Python project from other Python projects on your machine. And the defaults these days actually exclude the site packages or the things that are installed at system level, which is really great because then you're more aware of everything you're going to need. Build-out is the other tool that I think has fallen out of favor somewhat. I'm still a big fan. It lets you sort of declaratively configure your project and install applications again into an isolated environment. The real key here, though, whichever tool you decide to use, is specifying versions of your dependencies. So it's not enough to simply say I depend on Django. You probably really mean you depend on Django 1.3 or 1.4. And Django moves pretty slow, but other ones move much more quickly. So we've had situations, for example, where we did not specify dependencies, and all of a sudden we make a new build for staging, we're trying to test a release for the week, and nothing works. And you start to track down the stack, and what you realize is some dependency of a dependency had a new release, changed the API, and broke things that you were counting on. So by specifying versions, you're writing more testable code, and you're writing code that you're going to actually test what you're going to fly, right? And if you're using PyPI, you can specify by version number. If you're pulling from GitHub, which we do a lot with pip, you can specify the SHA. So that's a real specific version, a point in time of software. Right, use virtualenv. There's this thing called Vagrant. Has everybody here used Vagrant? Yeah, okay, so one person. So Vagrant lets you take a VirtualBox virtual machine and automate a bunch of tasks around it, and including provisioning it and doing things like installing dependencies. It works with Puppet. It's really great if you have an ops team or person. I wholeheartedly recommend isolating things so that it's a little more like what you're going to deploy on. So we go to begin your project, right? Django, yes.
Can I stop for a minute on dependencies?
Sure.
And I'm kind of a new Python guy.
Okay.
I've done a lot of Rails work, done a lot of Java work, done a lot of PHP work. Does Python world with Django have a concept such as like bundler that Rails has or Maven that Java has where you actually got some project file that you define the dependencies along with the version numbers?
So the question is, does Django and Python have something like Maven or Rails, I guess, where you're defining version numbers with dependencies with version numbers? Is that right? Right. So Django does not, but that's why you use a tool like pip and requirements.txt. So what requirements.txt lets you do is let me show you a requirement.
Maybe the answer is requirements.txt.
Yeah, and
like a bundler file in the Rails world.
yeah, let me just quick show you a requirements.txt. Well, let me show you two different things. So I have this slide software I use called Hieroglyph. Okay, thank you. Is that readable? So Hieroglyph actually uses build-out. I'll show you some of the other. So build-out files look like this. They have like any syntax, and you're telling it what you want to do. In particular, interesting here is this develop line, which says that this particular directory should be developed as a Python egg. The interesting part of that is there's a setup.py file, and here I have install requires equals 6. So I'm actually not following my own recommendation here. So consider this an anti-example, but this shows you how you can say in a module or a package what your dependencies are. Some things don't have setup.pys for whatever reason, for hysterical or historical reasons. So for example, wait, we're going to place. This is Eventbrite is one of those things. And when this file opens, I will show you. So this is an example where we use requirements.txt, and part of our Vagrant provisioner actually goes through, and you can see there's a lot of stuff in here. And they all have this like #MD5 at the end of them, which says what the actual SHAs are, what the hash should be to make sure we download quickly. And you see the very first one here is Django, and we're Django 1.3.1 right now. So does that answer your question?
Yes.
Yeah. Yes.
And that's kind of almost the flip side of that, though, is that you push your project up to high,
Uh-huh.
and you want someone else to use your application, you're locking them into different versions of your different
Totally.
So if you're on Django 1.4 and you just happen to be running Django 1.3, there's nothing. When you wrote your setup,
Right.
you said, lock me at 1.3. You didn't know that 1.4 didn't break 1.3 compatibility.
You didn't know that. Right. So the comment is that if you're going to push your project to PyPI and you use something like setup.py, you're going to lock people into particular versions. And is that an accurate paraphrase? Right. Yeah, it's possible.
If you lock your version, you're going to limit your users using your environment for many versions of their environment.
Totally. So my comment about that is, I guess I have two comments. One of them is that's totally true for libraries or sort of general purpose things. And in those cases, I would suggest using range requirements where you can say, I've tested this with Django 1.3 and 1.4 or something like that. But when you're building an actual site for yourself, I would not want to not lock them down very tightly. And that's just because I want to fly what I want to test what I fly and fly what I test. I want to actually have that. And so I think there's different considerations for different kinds of projects, and that's a great point.
I guess so we do some of the same.
Uh-huh.
We have applications, and the applications have general requirements that aren't locked down.
Okay.
And then we have a Python package with different sites, and those have locked down versions of the application.
Right. That's a great strategy.
So your application for, let's say, blog, Django blog, may require a package.
Right.
But the site for appy.inc.com has particular versions of the blog software as well as the Django package.
Right. Right. Yeah.
I think that's a good point, like DevOps conversation. I hear at Java conferences, I hear at Rails conferences.
Right,
I hear
right.
at my conference. What I use in development is free and loose with the version number or latest and greatest. When I QA cert, put it into a production environment, definitely I'll be locked down
Yeah.
with the version number.
Yeah. That's definitely a good point. So Django 1.4, as I was moving on here to the kind of scaffolding that Django provides for your projects, Django 1.4 actually made a change to kind of further decouple apps from projects. And in Django parlance, a project is your actual site, and the app are these individual pieces that you build inside it. There are many ways to figure out how to split up your site into apps, if at all. You might install an app for like Django tagging, as you mentioned, which provides kind of basic full autonomy and tagging support for things, or just there's a comments package you can install, that sort of thing. So those would be individual apps that you might add. If you're writing a bunch of code yourself, you may also find it helpful to split up things into apps. It's sort of a question of style. So I'm just going to run through a couple of examples here. And throughout the talk, I've got some code examples. And I use this idea of a contact manager as my example that I'm writing about. So I start a project. It's going to give me, so the thing to note here is that I call Django admin, which ships with Django. And I start a project called contact manager, which makes me this whole directory. And specifically, it gives me a manage.py and then my project directory here. And we're going to talk about each of these bits. We'll actually talk about two right now. One of them is settings.py, and that's the project settings. Django has a bunch of dials, and this is a great place for you to add your own dials that you'll be able to turn, or that you're going to need to turn. So we have things in here for our package at Eventbrite that's things like which memcache server should be used, and what are the database configurations so that we can hit master database for writes and multiple slaves for reads. And then we have a base version of this, and then our ops team pushes out the real configuration for the operational servers. This gives them one file they can actually just manipulate all that with. And then the app, so we can now call manage.py inside of our new project to actually start the app. Manage.py is actually pretty brain dead. All it does is delegates to Django admin, but it lets Django admin know, hey, the rest of these commands I'm going to give you, the context for them is this particular project. So that's pretty handy. When you start an app, you've got models, tests, and views put in there by default. And we're going to talk about all three of those in the next hour or so. So this URL file here is where your URL routing takes place. And this should look pretty familiar to most people who've used other web frameworks. But so basically, we're going to look at this first. So this is a really basic URL configuration. So it defines one URL, the index for this particular site. You can see, so this name URL patterns is actually important because Django URL comps are modules. They're not objects. Yeah, they're modules. So it's the entire module that makes up the URL configuration. And then within the URL here, we have the actual thing to match, which is a regular expression, and what we're going to call when that is hit. So in this case, it's going to look for a contacts app and views module inside of that, and then call index. This is a Python-dotted path. You can put the real up here, but you don't have to. So I mentioned that there's this URL patterns name that's actually important. There are special names you can put in this module to make Django behave more pleasantly when something goes wrong. So something for 403s, for access denieds, for 404s, not founds, and for server errors 500s. So these just all point to views. And the important thing here is that they should be really, really simple because you've already had an error occur or something go not quite right, and you don't want another one. And so we've had cases where somebody's tried to said, well, our server error page could be a lot more interactive and a lot more helpful to people if we only made some calculation to show them something context specific. Except then that's a great idea, except when creating the context is actually what blew up in the first place. And so now you don't have a context to be specific to, and nobody can see an error. The other thing to note is that URL comps import a lot when they get loaded the first time. So if you're referring to views directly, all those views are going to get imported, and everything they import is going to get imported. So it can be a non-trivial spin-up time, and the errors that could be raised, like if there's an import error because of a bug 3 levels down, can be really non-obvious. So if we see something that's pretty mysterious when we're testing a new feature, one of the first things we look at is just making sure we can drop into a shell and import our URL configuration and make sure things are okay. You can also name your URLs. This is a little aside that I find pretty handy, where you give a name and then you can reverse it. I see some people nodding their heads. I think Rails has something like this as well. But this is really handy so that if you your URL configuration becomes the place where mapping between code and HTTP happens. And then just finally, we're going to talk about views. We're going to talk about views in a few steps, so class-based views in particular. But I wanted to show you just the basic built-in views. Like I said, a view just takes a request and turns it into a response. And you can take other parameters too, but the first one always has to be the request. And so this is the simplest view you can imagine. Well, yeah, the simplest view you can imagine, where you have a name. It takes a request object, and all you do is return hello world. So this is not even using a template, not in the database. But this, and you can see that this is contacts, views, index, which is the path we saw in the URL configuration. Are there any questions at this point? Yeah.
Is there a way to sort of static HTML page for those errors?
Sure. So you could. So there's a. So you have a couple different options. Typically, a static HTML. You can't really serve it just off the file system with Django because there has to be some Python code in there somewhere to load it. But you can serve a template that doesn't actually. That's treated like a static file. And so I'll show you a little bit later how you handle templates, and that would be a way you could do just a plain file. That's ours are not quite static files, but they're pretty close. So they have a few conditionals in them about whether we should like the support phone number or not. But it's written in a way that that it won't blow up if things aren't there. So does that answer your question? Otherwise, they're just views. So great. So let's see how I'm doing time here. Yeah, what time is the break? Is it okay? I'll figure it out. So there's two different kinds of test group that you can write for Django, and it's important in my opinion to keep in mind what the difference is and be aware of what you're actually writing. There's unit tests, which test some unit of functionality, as it implies, and there are integration tests. Unit tests are only so here's why I tell new engineers that come to right. Unit tests don't rely on external services. They might rely on the database. That's like the one allowance I'll give, but they rely on like a SOAP service or some external third party, and they should be fast. They should be really, really fast because these are the tests that we want to run every time we're ready to push our code to master or up to GitHub. And it's important they're fast because they're slow. People will be like me and they'll be lazy and they won't run them and then they'll break the build and then we'll have to like backtrack 10 steps and figure out what went wrong. And that's a lot harder than figuring it out when you're just having your couple commits locally, right? So and they shouldn't rely on external services because if they rely on that constrains where they can be run and constrains what else you need to make them run. And there's two different reasons you can think about this being bad. One of them is that I want people to be able to run tests anywhere. I want them to test often and test frequently and test with abandon. And the other one is that then there's some configuration that has to happen. And now suddenly we've introduced another piece of configuration you have to manage just so you can test your code. So those are sort of the integration tests. Integration tests are things that test how your code integrates with other services. So now this might actually be something that makes a mock credit card transaction test that you're processing a declined response correctly from your payment processor, or test that you're able to actually communicate correctly with your cache servers. So Django 1.4 adds a bunch of functionality for integration tests and for doing sort of behavioral testing where you actually have a more full server up and going. We're not going to talk about that a whole lot, but that is there. A unit test, I'm going to show you a really simple unit test here. So Django bundles unit test 2 with it starting with 1.4, I think. Unit test 2 is an improvement to the Python standard library unit test, and that's been included, I think, since 2.7. So if you're running on like 2.6, you can basically always import the Django version and you'll be confident that you can use the newer features of unit test 2. So this is sort of the pattern. So your test case, in this case I've written a test for some middleware, and basically this is sort of a look ahead, but middleware is asymmetric. So part of it might run, part of it might not run. So this is a test that basically asserts that if I'm not that's a typo. If I'm not passing in a request object, that my middleware will still operate correctly. So this is sort of the extreme case where it sure the request side sure didn't run because there's no request there. But I want to make sure that my site will still be served. So you can see there's a few things here. We subclass from test case have a test defined, and the name actually most test discovery tools rely on the name starting with test something. And then we do some setup, and here's where we actually are calling the thing we're going to test, and then we make some assertions that something happened or something did not happen. Right. So there are many assertions you can use, but this sort of gives you a flavor. And the important thing here is this is a very, very fast test to run because we're creating a few things, but we're not actually making any calls or anything. So we created a response, but we're not actually returning it over the wire or anything. When you need to step up into integration testing a little bit, Django has 2 different tools I was going to touch on. One of them is a test client. The test client acts like a browser, sort of. And the idea here is that it's actually going to spin up your Django application and let you make HTTP requests against it. So it will create requests in memory. It will resolve them against the URL configuration. It will dispatch the request to the view, and it will give you back a response. So in this case, we make client. We do a GET request for /login, and we're asserting that the status code is 200, so that the login page is actually resolvable and working at this URL. And then you can also do post this way, passing in your post data as a dictionary. The test client is slow. It's very, very slow, and its slowness grows over time as you add more code to your project. So we have been able to achieve tens or hundreds of milliseconds shaved off of test time by converting it from test client to something that doesn't use test client. Test client is fantastic. And if you have 2,000 tests, that's actually interesting. Yeah.
Are you using continuous integration server to do testing?
Yeah. So the question is, are we using continuous integration? Yes, it's sort of tangential. We have Jenkins or Hudson, whatever the morally correct version of Jenkins or Jenkins Hudson is running, and sorry if anybody works for Oracle, and whenever stuff gets committed to master, it does a build, and there's many steps involved in that. But yes. Are we using Selenium instead of this? So no. Well, not instead of this. We are using Selenium, and that's something that I'm not really going to talk about a whole lot, but I can tell you that our approach to this is that there's the unit tests are things that will run really fast and things that we want people to run every time. Then there's a set of smoke tests that are kind of similar to this that we want to run, maybe not right before you commit, but every time we do a build to make sure that really poor pages still work. And then there's a full automation suite, which is Selenium and WebDriver, and it fires up a whole instance, a whole database, builds that out. And so our continuous integration server does these in steps. So if the unit tests fail, we don't even bother with the Selenium test because we know we have a problem already. So. Django 1.3 introduced this thing called the request factory, which is actually pretty interesting because it shaves off some of the slower parts of test client and lets you write tests for your views. So it does not do URL resolution. It does not do lookups. What it does is it just makes request objects. Hence the cunning name request factory. And then you can pass them to views. It's important to note that middleware is not run on these. So if you have views that depend on middleware, you can't use this. And basically the API looks exactly like the test client. So you make a request factory, and then you call .get, you call .post. But the difference is, instead of getting a response back, you get a request back, which then you just pass into your view object, or into your view. Django has a manage.py command to run tests. A gotcha is if you don't have models, you will not get tests. So you have to have a models.py even if you don't want one. And you can replace this. Their test runner is totally adequate. We use Nose for our test discovery, not because it's fantastic, but because it does coverage reporting for us, so we can see what our test coverage looks like. But that's there's the dial you tweak for that. And I'm happy to show somebody that later if they're interested. So I want to jump over to middleware as the next topic. Okay. Are there any questions about sort of the overview of testing before we move on? Great. So I think middleware is something that a lot of people sort of use but don't really think about, and I want to talk about it in particular because it's really useful. We use it a lot, and it can be the source of some really spectacularly subtle bugs. So I want to point out some of those things as we talk about it. Basically, middleware is a way that you can grab things that come in or leave your site and take some action on them. So there's a few different hooks we'll talk about, but basically it's a sequence of classes that get defined in your settings, and the basic one, the one that's included with Django out of the box, is these 5 pieces of middleware. So you have the common middleware, which is a little bit of setup, session middleware, which will look up your HTTP session for you, or store it back to a cookie when you leave, when the request leaves, cross-site request forgery protection, authentication, make sure the user is in the where you want it to be, and then, messaging lets you pass little messages to the users. But you can change the order or manipulate them, whatever. And then there's like 5 hooks here that you can hook on. You can trap things when the request comes in, when the response goes back, when the view is about to be called. And then you can also trap exceptions and template responses. So this is another way when you're doing error handling that you can take particular action or maybe just do logging when there's certain errors. And individual pieces of middleware, almost none of them implement everything. These are just the hooks that are available. You implement what you want. So we talked about some typical uses. But here's an example sort of that I was writing the test for before, where this is a simplification of what we use for our internationalization of the product, where we know users have a locale, we know we want to be able to translate content into that locale, and so we need to make that available to everywhere on the site. So we have middleware that comes in and basically says, hey, do they have a locale cookie? If they do, then assign that to the request. So we basically shove that on the request, and if they don't, we set it to none, and then we know that later we can offer them the opportunity to choose one of our many marvelous international experiences. On the other hand, when the response is going out, process response here, we look and see, does the request have a locale? And if it does, we set it into a cookie. So you can see how this sort of completes the round trip. The thing to note here is that here we do a get attr as opposed to just request.locale. And that's because we're not guaranteed that the request side is going to run. So we've implemented both of them, but we're not guaranteed they'll both be run. That's a really important point. On ingress, or when a request comes in, middleware is executed in order. But if any of this middleware returns a response, the rest of it is not executed. So you could use this for like an authorization check to make sure somebody's authorized to access your site, or maybe a maintenance middleware that you use to short circuit all requests when you put your site in maintenance mode. But basically, if this first method here returned response object, none of the subsequent middleware would get executed. But here's the sort of the gotcha, which is that when on egress, so when it's going back out, all of the middleware is executed in reverse order, even if the corresponding bit was not executed. So you look at it and you think, oh, there's symmetry, but there's implied symmetry, but it's not symmetry. Just simple. So I don't know if I was writing your own, but there's like 2 things here to point out about middleware when you're writing it. One of them is it's long-lived. So when your site comes up or when your process starts up, the middleware is instantiated, and that's the middleware object that's going to service every request until your process dies. So we use Nginx at the front end, start up several 2,000 workers per Nginx instance. And so when each of those 2,000 workers comes up, they create middleware objects in memory, and those are held on until Nginx until it kills off the worker. We had a bug one time where I would visit like the French version of the site, and then Ben here would visit the English version of the site, and he would see French content, and you can understand why that was distressing to us. And what it turned out was, over here, and we had this locale middleware, and instead of saying request.locale, we said self.locale. And you can easily imagine how, if things are not quite executed in symmetry, that my self.locale is still lingering now when Ben comes and visits the site. So there's supposed to request specific information, and it's cunningly called the request. So if you're writing middleware, writing things, generally they're going to be request specific or user specific. You write them on request and not on something that's longer lived cross requests. Does that make sense? Yeah.
That would be a good idea about the question is a great place to do browser detection to classify mobile, tablet, TV.
Sure. Sure. So that's another common use of middleware, is to sort of do that so that you can do it once, and then we've got some places on the site where we serve a different template or redirect a different view, we do the classification once, and then we can use it. The downside is if you have a big site like we do and you're not doing it, you're not providing the mobile experience in a lot of places, then there's a possibility you're introducing overhead for a lot of people who don't need it. So yeah. Right. That's just a great point, is that middleware gets run for every request. So be thoughtful about what you put in there. So finally, I just want to comment that there's a thing called WSGI middleware. WSGI specification defines middleware. It's similar. It's not the same. It's confusing. So be aware. They're different. So the next thing is class-based views. And I'm kind of thinking we're close to break, right? 10 minutes. Let's get started. What's that? Yeah, let's start with this and see where we get. So there's 3 big chunks left here, and yeah. So Django 1.3 introduced this thing called class-based views. Class-based views are exactly what they sound like. They are views that are based on classes. But more importantly, they allow you to compose a view from different pieces. So you can sort of make your particular class focus on what makes that view special and incorporate like authentication from somewhere place else. There's lots of power here, and there's also a whole lot of complexity. So this is my first attempt at sort of providing a treatment of class-based views, and we'll see how it goes. So the most basic class-based view is use subclass view, and you implement a method that matches an HTTP method name. So in this case, this is sort of an idea that you have a contact list view for our contact manager, and you can see we've subclassed the view class, and we've defined a get method on this class. So now if somebody posts, does an HTTP post, HTTP head, or some other method, they're going to get a method not allowed. So we've been really explicit that this is the only method that we're going to support. Using so that's sort of basic, but you almost never wind up implementing these directly when you start subclass things. So here's an example of template view, which provides a lot more scaffolding. It provides support for loading a series of template names off of, in order from the file system that finds them, and then giving them some context data. So in this case here, we've said, hey, this is just index.html template, and here's some context data that you're going to need in order to render this template. Yes? No, this is not inheriting from my place. Thank you. Right. Work on GitHub and submit. No, so this should be implemented from, this should be subclassing template view actually. But this is one of the really common idioms where you have get context data, and you're just providing the things that are specific for your contact list. So your template might also need things like the current user or the request or something to be rendered. That's how scope for this. You're just doing what's needed for the for this particular view. And we're going to talk about why this is important in a second. So if you remember, the URL conf expects that you're going to give it a call, right? Expects you're going to give it something that can be called with a request and get back a response. So one of the sort of things that feels a little kludgy about class-based views is that you have to call this as-view method on them. So as-view gives you back a callable that will then dispatch things. So there's a little bit different invocation in the URL configuration, and that as-view ends up putting a bunch of stuff onto the class for you. So there's a lot of mixed things. They can be confusing, but there are a few idioms that we're going to talk about. And so, usually, so I hope that we talk about this and you'll kind of have a sense about where to start looking when you want to do class-based views, because they're actually pretty, they're very useful. We found them very useful, but very, they are confusing. So we just talked about the template view class, and so there's 4 bits here that I want to talk about. So we showed get contact data and the template name. Then there's this response class property, and this lets you actually say, I'm going to return a JSON response, or I'm going to return something other than just HTML. By default, it's just going to be a regular HTTP response class in Django, which says just give. Sorry. So there's a render response method, which is pretty idiomatic for these things that actually have some template or some construction going on, and the default implementation instantiates your response class and returns it. So so that lets you do some customization, like do a JSON response, do something else. We're going to talk about this more a little bit later, but for forms, there's also this process form view. If you've heard of Django forms, there's some boilerplate involved in how they recommend you construct the workflow. So this eliminates all of that. This is one of the biggest wins, in my opinion, of class-based views, is that it lets you really strip away a bunch of that boilerplate for forms. But you have a success URL that you're going to go to if your form is successful. You've got a form valid action that's going to get taken and an invalid action. That's it. That's all you have to define. And finally, there's also a subclass of that for editing, and you can actually automate things like, or simplify things like object creation and updating using these editing views. And so basically there's a get object that returns apps you can actually work on, and there's a model that you can define, and it will automatically do that. And we'll talk about that some more too in the forms section. So I mentioned earlier that you name things based on HTTP methods. By default, this is what it supports in Django 1.4. So it's pretty thorough, but if you want to say you support HTTP patch for some reason, you've built some API that does patch, which would be pretty cool. You're going to need edit method names on your class. Anything that's not in this list will get a method not allowed. So I mentioned the super call, and that we saw in that earlier example. The super call is super important because it lets you mix things with others. So here's an example. This is a gross simplification of something we use at Eventbrite, where we have lots of pages that, perhaps unsurprisingly, have events on them. And a lot of them are just one of many pages for a particular event. And so this is a class-based view mixin we made that lets us provide that event into the template context so it's always available. So this is a way we can abstract out part of this work that we were repeating in lots of places. So there's 2 things to note here. First of all, we have this getEvent method that's specific to this view, or to this mixin. And it delegates to some other thing that you import somewhere else. I'm sort of trying to wave my hands and simplify this sufficiently. But you can see it caches it, so it only does it once, and then it returns it. And then you have get context data, which is one of those idioms we talked about. It calls super, and then returns a context. And this means that when you're composing event page mix-in with something else that also has the context data, you're not going to step on their toes. So if you didn't call super, you would lose things further up the chain. This lets you sort of continue to add things as you walk down until you get to your base or to your concrete view. That makes sense? Yeah. Object. Yes. The idea here. So keep in mind that super is a little bit funnily named in Python. It's not called on the superclass. It's look up this method in the method resolution order and give me the next one. So the idea is that this mixin will always be used with something that subclasses from view, right? And view implements get context data without a super. So that's sort of the end of the line. So this is actual.
So it's not just going to objects.
That's right. Yeah. So if you, I don't know if I have markers. Yeah. If you just imagine that object sort of falls out of this because it's using the method resolution order. And yes. Is that actually? Oh. Okay. Yeah. So I don't know if people can see this, but so if you have view, and then you have your and you have object, and you have your mixin, and then you have something that inherits from both of them, right? So you have some mixin you've defined. You have some view that inherits from view and your mixin, right? When super gets called here, it actually doesn't go up. It's called in the context of a my view instance. So that first argument you pass into super, or the second argument, I'm sorry. This is sort of a digression, but this is where I'm at now, and what is the actual instance I'm working on? That instance is a my view instance. It's not a mixin instance. So when you're up here and you say, hey, what's the next one? It's like, oh, there's not one up here. It's going to be over here. And this is there's a dependency about what order you find things in, but in general, view should always be last in your inheritance tree. Super is more, it handles things like this, A, B, C. It also handles diamond-shaped inheritance, and it does it correctly and deterministically. So some people don't like super. Some people think it's evil and too confusing. I think super is super. So yeah, thank you. So we kind of have to do that, but I think it's about break time at this point. So but I'm going to go ahead and take 5 or 10 minutes and come back, and we're going to move on to the database layer and forms, both of which I hope will be informative. Thanks. 2 big things we didn't talk about yet. One of them is the ORM and one of them is forms. So let's get started. So when you write, the ORM is the object relational mapper, and it's what takes rows in your relational database and turns them into objects, hence the clever name. You write models with this declarative syntax, which is sort of interesting because you're defining 2 classes here. These are going to correspond to tables. I haven't given any names for the table, so it's going to infer them for me from the application and the model name here. You can see that the slide is complete with typos, and these different fields take different parameters. So like character fields have a maximum length, whether they can be blank or not. Date fields let me set them to now automatically if I don't specify a value. There's things like email fields, which are really just character fields with additional validation, that sort of thing. The one thing to note here is I have a foreign key. So this says that the address is actually going to be an address ID column, and it's going to point to an address model. And when I look at the address property of a contact, I'll get back an address model that exists, not the ID. So under the hood, Django will take these declarations and process them and actually put them into instance-specific lists, which basically means there's some things you end up doing that you think you're operating on a class property when you're really operating on an instance property. And that's because both models and forms use metaclasses extensively to control construction. So this list should look a lot like working with regular Python objects. If I'm going to make a Nathan contact, I instantiate contact, I set the properties, and I call save. No big deal there. But right. So in model, this is what I'm rethinking now, but I'm going to say it anyway. Models should encapsulate your business logic. They should define how your data is stored and what operations you can take on it. And this will encourage testable code. So this means, I'll show you an example in a moment, but basically, if it's going to operate on a model or on a contact, defining it as a method of the contact model is a whole lot better than doing the operation and kind of as a one-off inside of a view somewhere. If it operates on a set of your models, so say I want to operate on multiple contacts, then that's going to go to something called the manager. So yeah, so this is kind of out of order, I guess, but saves the entire model. And I just want to call this out because this is another place you can kind of get into trouble if you're not aware of this. Basically, if I load an instance of the Nathan contact and somebody else comes along and loads it and makes some changes, and then I save mine, their changes are gone, even if I didn't change the same fields. So Django, when you call save, it's doing an update, and the update includes all the fields in the model. There's something called Django dirty fields, which is a mixin you can use, and it keeps track of what's been changed. It doesn't change the save behavior by itself, but it does let you keep track of this so you can do things like, you could conceivably overwrite save and leverage that information to execute a very targeted update. So I mentioned this thing called managers. Every model has a manager, and by default, it's the .objects manager. And this lets you operate over the entire collection. This is how you also start querying your data. So here's some examples where I say objects.filter, the last name is Urbler. And here's another example where I say the address state is Ohio. So two things here. First of all, the filter here is actually sort of delegating to a query set. And the double underscore has semantic meaning in the ORM. So it can, but unfortunately it has two semantic meanings. The first example here is where we're using it to define what sort of test we want to apply. So iExact is short for case insensitive exact. So this basically says if I want to get all of the contact objects whose last name is Urbler, regardless of how it's capitalized. The other way is this address underscore state here, excuse me, where it's actually says we're traversing a foreign key. So this says, hey, join us to the address table, and then show me contacts where the state column on address is Ohio. So we're actually making that. You can make that. Yeah, you can do multi-step traversal. That doesn't mean you necessarily should, but you can. And you can use them together. So I could say address double under state, double under iExact is equal to lowercase oh, for example. Or there's like set operators too. So the Django query set documentation is actually quite good in terms of going through all these options. I just want to call out that these looks like they're similar operations and they're not. But so managers are the place you put stuff that operates over sets of your data. And you can override the custom manager if you're going to do this. So here's an example of maybe a common operation for my contact manager is that I want to get out a list of all my contacts that have email addresses. Because I'm going to compose an email, and I have contacts with a phone number. I don't want to see those in my list. So I've defined this with email method here on the manager, and it's going to return all of the contacts where the email is not empty. So any is not equal. And then down here in my actual model, I say objects is equal to a new contact manager. So two things I want to point out. One is that the manager is shared across all instances of your model. So we're instantiating it once here in the class declaration. And second, this lets you, okay, yeah, so and second, self.filter, you're already operating on the manager, so you wouldn't call contact.objects here. It's just, you're already there. There have been times we actually needed to really heavily customize managers. I want to just point out how you do this. So at Eventbrite, we started the site before Django even existed, and so there's still a large chunk of the code that is not Django-ified, and there's data in the database that has slightly different semantics than Django, right? So Django has certain semantics for when you don't have it. Basically, Django stores a null value when your foreign key doesn't point to anything. Our old code stored a 0 for historical and hysterical reasons. But we need our managers to actually operate with this, so we have a customized manager we use everywhere that knows how to handle this. And one of the things we did was override get query set. This is like the lowest level, not the lowest, it's one of the lowest level bits of manager API. And basically, everything else changed off of this. So when you call objects.filter, objects.update, objects.whatever, all of them call get query set first. And so let's talk about testing models. You want to test your business logic that you write, and you want to test your customized manager method. I think that, basically, you don't, what I'm saying here is you don't need to test that it actually saves. You don't need to test that loading works. Django has pretty darn good test coverage. That's not code you wrote, and I'd be hard pressed to fix it if I think it's more likely that I find a bug in my test than I would find a bug in their stuff, probably. And it's not something you're necessarily going to fix anyway. So focus on what you're writing, what you're responsible for. Here's an example of a test for an objects thing, for a manager method, where I'm making two different, I'm basically testing my with email method, and confirming that it really returns what I expected to return out of the database. This is a slight violation of my don't interact with external services suggestion. Django luckily handles a bunch of this for you. So when you write a test it actually creates an entire copy of your database schema for you on the fly when it starts the test. All your tests operate in that test database, and when they finish, it tears it down. So you can do this pretty easily. And the assert equal, I think, makes sense based on our previous slides about tests. But here's another manager method, create. And create is basically a shortcut for insert, a SQL insert statement. So instead of doing create an object in memory and then set some properties and then save it, here you can do it in one shot, creating an object. So what if we don't want to involve the database when we're doing these tests? What if we're testing our business logic and we really want to, we want to make these as fast as possible and really focus on what on the logic? There's a package called Factory Boy that we used that I really like that lets you do this. So here's an example. What you use, you make a factory, and then you use this factory to make objects. Sounds pretty straightforward. Basically, it knows how Django models work. So here's a contact factory. You tell it what it's a factory for. So it's a factory for my contact model. You give it some defaults, in this case, John Doe. And now I've got an object I can use to start making objects. So if I call contact factory.build, I'm going to get an object in memory that's not saved to the database. So this just does the initial instantiation part and sets the fields. It doesn't actually save it. So just doing .build is going to use all the defaults I have. So first, it's going to be John Doe. I can override one of them by passing it as a keyword argument. And then if I actually do need to write it to the database, I can call .create. So you can see this lets you, if I do the nice shortcut, if you're writing a lot of unit tests, you can actually create the fixtures around your tests much more quickly. And it also handles subfactories for foreign keys. This is actually where it really shines, in my opinion, because when you're writing tests that are kind of when you have a test that's going to traverse multiple relationships, it can be a real pain to create all those objects and get them put together. So here I made an address factory, and I might have this one in the wrong direction, actually. Anyway, you can kind of see that you get this idea about a subfactory, right? So, and then you can actually do the traversal, where it's actually called the other factory at the same time to instantiate both objects. We showed a little bit about querying here. Queries are chainable. This is pretty. I'll tell you why you shouldn't do this in a moment, but it actually is pretty powerful. So you can pass around a query set. You can call other methods on it to get a new query set, and they're not actually evaluated until you try to access the data. So at this point, if I would execute this command, there's no database access involved. It's not until I actually ask it for the first record, or say swear back at 0 to dereference it, that it's going to have it. And these are SQL ands, so all the conditions have to be true. There is this thing called a queue object where you can do ORs. And you see they look pretty similar to the previous example here where I'm saying either the state is Ohio or the email ends with osu.edu. You can actually pass those in for ands as well if you want to use them everywhere for consistency. You don't have to. So let's talk about some performance things. Instantiation is really expensive. The Django ORM can only instantiate about 40,000 objects per second at best case. And I hope that you all have the delight of working with sites that have more than 40,000 rows in the return set. So these queries are lazy. They're not evaluated until you try to access them, but then they're evaluated, and that can be expensive. And so here's an example where if I'm trying to send an email, I'm saying for user and users, the object.filter is active. So basically give me all active users, and then send an email using the user email address, right? But this will take a long time with a lot of users. So there's two things, one's values and one's called values list. And these basically let you do the query and avoid instantiation. So here's the exact same thing rewritten so that I don't instantiate those user objects. So what I do is I do my filter like I did before, and then I say values list. And now I can give it any number of arguments and say, these are the only values I care about. The flat equals true says, just give them to me in one big list of emails. So we've seen multiple order of magnitude performance increases by avoiding instantiation when we're dealing with large batch processing. Because it's not just, even if you're only iterating them one at a time, that's a lot of stuff to instantiate right away. Traversing relationships can incur additional queries. So here's an example where, so basically when I go to follow a foreign key, if I don't have that in memory yet, I've got to go get it from the database. So now I'm making 2 queries instead of 1. If you know you're going to need it, you can use something called select related. And this basically says, hey, when I'm going to make this contact query, and it's got a related field called address. So when you go and do the get or do the select from the database, get me the address data too, pretty please. So that lets you avoid the extra query. And finally, I said I was going to tell you why you should not chain if you can avoid it. Query sets maintain their state in memory as you go. And when you do that chaining, so you say filter something dot filter something else, you end up cloning your initial query set as a starting point. Query sets are not small objects. They are actually pretty huge, especially after they've started to load data from the database. They maintain a cache. And So that all gets duplicated in memory. So if you can avoid filtering, or if you can avoid chaining filters, do so. You will see better performance. So finally, I just want to talk about falling back to raw SQL, because Django has to be database agnostic, but you don't. I mean, presumably